Welcome. This lesson is from page 198 and 199, and you'll be able to solve and graph two-step inequalities with one variable. So your essential question is, of course, what steps do I take to solve and graph a two-step inequality? So a good definition is a two-step inequality contains two operations, and like you did for the equations, the inequality is similar because you undo the addition or subtraction first, then undo the multiplication or division last. So truly it's the opposite of PEMDAS. All right, our first example here is 5x minus 6 is greater than or equal to 44. So first we undo the addition and subtraction first. So the opposite of subtracting 6 is adding 6. And if we add 6 to this side, they would cross each other out. And then you would add 6 to the other side, and it would become 50. So now what you have left is 5x is greater than or equal to 50. Divide by 5, divide by 5. And now you have x is greater than or equal to 10. Graphing. Because it's or equal to, you have a closed dot, and greater than because the x is greater than 10 and the 10 is the littlest, and so you'd have your arrow going that way. Next equation, 9 plus 2x is greater than or equal to 15. Just like before, you look and say, oh, it's a positive 9. I need to undo that and move it to the other side. Subtract 9. Those two cross out. Subtract 9 on the other side. 15 minus 9 is 6. Oops, I gave you a little too much early. Then 2x, you want to get the x alone, so divide by 2. Divide by 2. X is greater than or equal to 3. Graphing it then, you think to yourself, x has to be greater than 3. 3 is the littlest, or equal to. And so you'd have a closed circle on the 3, and x is greater than. Next equation, or inequality, I should say, next inequality, you'd have x divided by 2 plus 9 is greater than or equal to 5. So you'd say I want to undo the 9, subtract 9 from both sides. The 9s cross each other out. And 5 minus 9, you'd say opposite signs. Subtract and take the sign with a large absolute value. And so you'd have negative 4. Now you want to undo the fact that x is being divided by 2. So you would multiply times 2, multiply times 2, and x is greater than or equal to negative 8. So graphing, you would say negative 8, and because it's or equal to, you have a closed circle and the arrow going this way. All right, 8 minus x divided by 3 is less than or equal to 7. First, you want to undo the 8 because you want to get the variable alone. So you have a positive 8. You want to subtract 8. If you subtract 8 from this side, the 8s cross each other out. Subtract 8 from this side, and 7 minus 8 is negative 1. And then here you think, oh, I want to get the x alone, and right now it's being divided by 3. So you multiply times 3. Oh, I'm sorry. Multiply times a negative 3 because there was a negative right outside here. Multiply times a negative 3, and you would actually have x, and you would flip the inequality and say x is greater than or equal to a positive 3. All right, so because you multiplied both sides by a negative number, remember to flip the inequality. So x is greater than or equal to a positive 3, and So you graph it that x is greater than. All right, looking at the examples, some students are still struggling with setting up word problems. And so I'm looking briefly quickly at page 199 where it says, halfway through a baseball season, Stewart has 34 hits. He averages 2 per game. So you would say, so far he has 34. He averages 2 per game. So you hear the constant and you hear the variable, how many per game. Write and solve an inequality to find how many more games he needs to have at least 61 hits. And so you would set it up like this and then go ahead and solve like we've been doing. And I think the harder part there is setting it up. All right, well done on the notes. That was probably a record for the shortest notes. Hopefully I didn't assume you were understanding anything. And I'll see you in the morning.